It's also called the English system. But even the English don't use it anymore, they gave up on it. So we're the only ones left with it. Sorry.
You know what, I think I meant 23, I put my asterisk.
You remember
Asterisk kind of weird.
23?
23.
Oh, okay. And you can tell it's an archaic system. I mean, just from the way it's built, you know that it was sort of cut and paste over hundreds of years. You know, the foot, well, everyone's foot's a different length, right? Mm-hmm. And the mile and the yard and stuff like that. Those all vary upon, you know, the person you're talking to. So it's a very silly system. Now, of course, there are standards in the Bureau of Weights and Standards in Washington and so forth. But the rest of the world doesn't use this system. So we're going to have one more section on this, 7.2, which we'll do today. And then we'll feel great relief because we'll go to the metric system, which is so much easier to use. And, you know, do what you can in your lifetime to get this changed. I mean, this is just stubbornness. That's all it is. I mean, it's just people saying, I don't want to change. Okay? All right, identify an appropriate ratio to convert yards to feet by using multiplication. All right, so we want to go from some number of yards, we don't know what it is, but it's some number of yards to some number of feet. And they want us to create the ratio which will do that. Now, this is really a question about, do you understand how these unit ratios work? And I'm sure Mr. Schmid explained this to you. Do you want to do it now?
Sure.
Okay, fine.
Wait. I can do that also.
Oh, no, that's fine. Well, I'm just beginning, so this is a good time. Okay, there's going to be a survey, and I will be back.
10 minutes?
And Elizabeth is next.
Have you guys ever done these before, process or student evaluations? Okay. What we ask you to do is, well, actually, what we give you the opportunity to do is to assess how you feel the class is going and what you think about Mr. Little, and he will see these at the end of the semester once the grades are turned in. So they're completely anonymous. And it does ask you to use a blue or a black pen. If you don't have pens because you're in a math class, I have pens for you. Yes. Is there an interpreter? Who's?
I lost my pen.
Okay.
Wait.
Okay.
No,
They can probably read it.
Yeah. Okay. I will find it. So I've got pens here.
do we have to give them back? No, I'm
Pen?
kidding.
Highly,
Is there, do you guys do these for all teachers?
It's on a cycle, so it's eventually all teachers get these done, but in every semester, may not be every single instructor, this depends where they are. Anyone do that back here?
Right with the opposite end because they know you're ready.
Oh, you guys have it. Yes, it depends. Okay. So what we ask you to do is make an X, not a check mark. Then I have to go through and make all the check marks into X's. And then if you make a mistake, fill it in, and then put an X.
These two right here.
I'm going to talk to them, yeah, I'm going to talk to them.
Oh, you're not silent?
No, but I'm going to do that.
These are student evaluations. So it's anonymous. So it's anonymous. Don't to read that and put an X where you think is appropriate. And use a pen. And then just fill out and make sure that you have, do an X. Okay, where you think. Okay, and then on the back, just write if you feel like it. Okay, thank you. You're done with it? Okay. No name.
No, no.
And he'll get them at the end of the semester once grades are turned in.
Okay.
Thank you. So you guys liking your arithmetic so far? And take the algebra next semester? Intermediate beginning algebra? Yeah. Fully expect to see all of you guys in the calculus class in 2 semesters. You guys all go to the Math Center ever? Do you have questions? Yes. Thank you.
that, I'm not. We gotta learn everything over again.
Okay, so we want to know what the multiplier is to go from yards to feet. This is what's called the unit ratio. And what it looks like is something like this. You have some number of yards. They didn't tell you the number, but they did tell you the unit, so you know it's yards. Okay, so you want to multiply it by a fraction, which will get rid of yards and give you feet. So in order for that to happen, you have to have the feet in the numerator up here, and you have to have the yards down here. Why? Because then you can cancel out yards just the way you cancel out numbers. Okay? You've got a 2 in the numerator and a 2 in the denominator, you cancel them out, right? Okay, well, cancel yards the same way. And look what you'll be left with, feet. Okay, so in terms of the answer to the question here, you want to look for something that has exactly that. Feet over yards, and that happens to be A. A is the only one that does. Well, that's not true. I'm sorry, D also does. Either A or D. Okay. Now the numbers are wrong in D though. It has 1 foot is equal to 3 yards, which of course is wrong. But 3 feet is equal to 1 yard is correct. So A is the real answer. No, that's right. The units are correct in D, but the numbers are incorrect. Yeah. Okay, anything else? Yes. 7? Okay. One foot equals 1/3 of something. So you got to figure out what the unit is there. Okay, the best way to do that is go back to your table. It's on page 410. And they show you there that there's a relationship between yards and feet. Now, they write it in 2 ways, notice. One way is to write it this way. 1 yard is equal to 3 feet. But they also write it the other way, that 1 foot is equal to 1/3 of a yard. Okay, those are exactly the same thing. They look like they're different, but they're not. Because what's going on here, they took this equation right here, 1 yard is equal to 3 feet, and simply divided both sides by 3, and they got that one. So it's the same equation. And it tells you that 1 foot is equal to 1/3 of a yard. Okay, so either one of these is correct, and the question is, what do you use? Well, here you're going from 1 foot, and therefore you would use this one. 1 foot is equal to 1/3 of a yard. Okay? So these conversion things can go either way. You can use them with feet on the top, yards on the bottom, or yards on the top and feet on the bottom. Just got to get the numbers right, that's all. But they can be used either way. Any others?
Number 81?
81.
We're only going up to.
I think, yeah, we're only going up to 41 right now, because we haven't finished this section yet, so we have to finish it before we go to 81.
41.
Okay. 41?
Yeah.
Okay. Okay, 0.8 miles is equal to how many inches? Okay, now we're going to have to go back to the table and get our conversion factors and stuff like that. What we know is we're going from miles to inches. So we want to take the 0.8 miles and multiply it by a conversion factor, which is going to cancel miles. We don't want miles. We want miles down here so we can cancel it. Okay?
What I couldn't understand is how do you decide if you have to do a multiple?
Well, we're going to get to that.
You'll be able to tell? Okay, that's fine.
Sometimes go around the barn, but I get there. All right, so you'd like to have inches up there, and you'd be right at the answer. But there isn't a conversion factor from inches and miles, right? If you go back to the table on 410, there's no such conversion factor. You've got all feet in inches, and you've got miles and feet. Okay, so what we can do is go from miles to feet very easily, huh? Because we know that. So if we go with feet up here and miles down here, that gets rid of miles, but leaves us with feet. We haven't gotten to inches yet. So that means we are going to have to use another conversion factor. So it's one that will have feet on the bottom and inches on the top. And that way the feet will then cancel out, and there it is, that's what we want. We want inches, huh? So in this case, 2 conversion factors are necessary. Sometimes they even have to use 3, but very rarely more than 3. Okay, so what is this one going to be? 1 mile is equal to how many feet? 5,280 feet, that's right. And this one over here, 1 foot is equal to 12 inches. So now we got the numbers in, but notice you got to put the units in first, because that way you'll get the numbers in the right place. Yeah, make the units such that the denominator unit cancels with this one, the one you're going to want to get rid of. And the numerator unit is the one you're looking for. Now in this case, we couldn't get to it right away, we had to do another one over there. All right, so now, what does this amount to? It's 3 fractions. Think of this as a fraction being over 1. We're multiplying 3 fractions. And what do? We multiply numerators, multiply denominators, as always. So it's going to be 0.8 times 5,280 times 12. 1 times 1 times 1 is just 1. And this is going to be in inches because we've canceled all the other units of measurement. And so you put that in the calculator, and my book says you get a large number. Yeah. 50,688 inches. So 8/10 of a mile is over 50,000 inches. Whoa. All right. Any others in this section there? All right, let's continue. We've got to finish this section first before we go on to the next. And the next thing to do is adding and subtracting mixed units. Now, you remember mixed used in another way in mathematics? We have mixed numbers, don't we? Yeah, and they're combinations of whole numbers and fractions, huh? Well, now we're going to have mixed units. And actually, we deal with it in a very similar way. In other words, let's say you're doing a carpentry situation. And you have 2 pieces of board, and one is 4 feet, 3 inches, and the other one, let's say, is something like 6 feet, 2 inches. What you've got is mixed units here. Okay, here's feet, here's inches. A foot is not an inch, they're different things. Okay, it's very similar to having something like this, 4 1/3 and 6 1/2. Let me just call it 6 1/2. So we won't get confused here. All right, these are whole numbers, these are fractions. Whole numbers, fractions, huh? So what do we do with the mixed numbers? What we do is this, we line them up vertically, 4 1/3 and 6 1/2. We add them, we create columns. We know we're going to have to get an LCD here, so we might as well put in another column. The LCD for 2 and 3, 6, and we convert to the LCD. We add those up, we get 5, 6, then we add these up, we get 10. Okay, that's how we do mixed numbers. We're going to do a very similar thing here. We're going to add these things in the following way. We're going to add inches to inches, we're going to add feet to feet. Okay, 3 and 2 gives you 5 inches, 4 and 6 gives you 10 feet. So that's how much board you've got. You've got the sum of those 2. Now there are times when you need to carry and transfer things, so let's put some other numbers in here so we can see where the more complex situation arises. Suppose you have 4 feet, 6 inches, and this is the standard way of writing feet and inches. If you were in the carpentry business, that's what you'd write. You wouldn't actually write out FT and IN. I want to add that to 2 feet, 9 inches. Okay, we don't do it horizontally, we do it vertically. So it looks like this, 2 feet, 9 inches. Come over here and add it this way, forget about that. All right, 6 inches added to 9 inches is 15 inches. 4 to 2 is 6 feet. Now the problem is that's more than 1 foot. So we split it up. We take the 15 inches and we say, okay, that's 1 foot plus 3 inches. 1 foot being 12 inches. Okay, so we take the 1 foot, put it over here with the feet, and make it 7 feet, and then we've got 3 inches left. All right, this is 7 feet 3 inches, huh? Okay, so that's the carrying process. Now, if you're doing subtraction, then you can have what you might expect. You have to borrow. So you have something like this. Let's say 8 feet 2 inches, and you want to subtract 3 feet 6 inches. Okay, it's kind of the reverse process going on here. We don't have enough inches up there to do the subtraction. So we go next door and borrow. We borrow 1 foot, which means that's now 7 feet. And we take that 1 foot and make it 12 inches, of course. So this becomes 12. So what we really have is 7 feet 14 inches, subtract 3 feet 6 inches. Well, 14 of them, take away 6 of them, leaves you with 8 inches. 7 take away 3, 4 feet 8 inches. Huh? So we borrow between units, so to speak, just like you carry between units. But it's a very similar thing to the mixed number right here. Now, where is this used? Well, it's used in a situation where they give you mixed units. For example, here, they tell you that this is 1,056 feet, and this is 2.2 miles. Maybe it's the median for a highway or something like that. Huh? All right, you've got miles and feet, and they ask you to get a perimeter. It's like trying to mix apples and oranges. They don't mix. You got to get 1 unit. In this case, your book decides to take that 2.2 miles and convert it into some number of feet. You can do it the other way. You convert the feet into miles. Either way is fine. It doesn't matter. Okay, so we need a conversion factor here, which will go from miles to feet. So we want to get rid of miles, put the miles down there, and we want to get feet, so we put it up in the numerator. All right, so 1 mile we already know is 5,280 feet, huh? So we end up multiplying these two things together, which gives you quite a bit. That's 11,000, yeah, 11,616 feet. And miles have canceled out, you're left with feet, so that's what you want. Okay, so now we've got this number, 11,616 feet. Now to get the perimeter, you need 2 of those and 2 of these, so you'd be adding up this kind of stuff. And this is all in feet, so you're going to come out with feet, of course. Turns out it's a huge number. It's 25,000 rather, 344 feet. That's the perimeter of that rectangular area. And it does happen occasionally that you do get a real world problem where you've got mixed units and you've got to convert to one or the other. Okay. On page 414, you've got this series of pipes. A plumber needs 5 pipes that are 8 feet 4 inches each. What is the total length of the piping? 5 pipes. Okay. Well, we could keep adding that to itself 5 times. It'd be kind of a waste of time, but you could do it that way. But that would be repeated addition, and repeated addition we call multiplication. And that works for mixed numbers, it works for mixed units also. So you could take that 5 and simply multiply it by 8 feet 4 inches. Now remember, this actually is an addition problem in here. They don't often write it as an addition problem, but really this is 8 feet plus 4 inches. So when you're taking this 5 and multiplying it by that, you have to do distributive law. You've got to multiply that by it, you've got to multiply that by it. So 5 times 8 would be 40 feet, and added to that would be 5 times 4, which is 20 inches. And once again, that's more than a foot. 20 inches is 1 foot, 8 inches. I'll show should stick to one or the other. That's right, this is 1 foot 8 inches. So you take that 1 foot, put it over here with those, and it gives you 41 feet, and then you're left with 8 inches more. So the total length of the pipe would be 41 feet, 8 inches. They even have one where you're doing a division problem here. It's on page 415. The carpenter has a board 6 feet 10 inches in length. He must cut the board into 2 pieces of equal length. 6 feet 10 inches, cut into 2 pieces, that means cut in half. There it is. You want 1/2 of that board, huh? And remember, these are added. So when you're taking things that are added or subtracted and dividing the entire thing, you want to divide both of those numbers by that 2. So that'd be 6 over 2 feet plus 10 over 2 inches, or 3 feet, and then we write that as 5 inches. So each board would be 3 feet 5 inches. So it's easy to play with this. It's, I mean, there's no excuse for the complexity of the US system. They've developed over a long period of time, and it's just a pain for everybody. But actually manipulating the numbers, writing them and multiplying and dividing them, not that bad. The next section is just about different kinds of things. This is all about length. We're going to do time, we're going to do capacity, we're going to do weight, and the process is exactly the same. No difference at all. Use the conversion factors, sometimes more than one. And that'll be the end of the US customary system, we hope. The big table, meaning the table that you should Xerox and put in your cheat sheet for Friday, is 7-2. It's on page 419. And they do it as a rectangle. I'm not going to put everything in here, but they split it into 4 sections, and you've got length up here, and time over here, and you've got capacity here. Now, capacity is the same thing as volume. And then they have weight over here. And there are just a couple things about this table I want to point out, because unfortunately it's confusing in many ways. Okay, now let's talk about the room. If we're talking about the perimeter of the room, we're talking about a distance that goes all the way around. It's that plastic board down at the very lower part of the room. You add up all 4 walls, you've got perimeter. Huh? That's called a distance. So that would come under the name of length here. If you want an area, you'd be talking about how much carpeting goes inside the room. So you'd have to do something like take that length, multiply it by this length to get an area, and you get square footage or area. If you wanted to know how much air is in the room, you're talking about 3 dimensions then, huh? And the way you would do that is take the area of the room, which you get for the carpeting, and then multiply by the height of the room. And that third multiplication gives you volume. And that's what this is. This is volume. This is a 3-dimensional thing, whereas area is a 2-dimensional thing. The point that I want to make here is probably something you didn't notice. Under the capacity, they tell you that one conversion is this. 1 cup, which is known as a C, just a C, is equal to 8 fluid ounces. That's a standard cup. And the abbreviation for fluid ounces is FLOZ. Okay. But if you go over here to the weight, you find out that 1 pound, which is not PD, it is LB, nobody knows why, is equal to 16 ounces, which is still OZ. And that's confusing, isn't it? When you see ounces, you know, if you're used to working, let's say, with weights, and you see ounces, you say, well, that's got to be a weight. No, it's not if it's got fluid in front of it. Then it's a capacity. Is everyone following all this? No, of course not. You're not interested in this at all. Nobody's interested in this. The President of the United States wouldn't care about this, really. It's boring stuff. There's no doubt about it. But, I mean, not only do we have all these weird conversions we have to go through just for length, let's say, but then we're calling this by a very similar name. But they're different things. They're physically different things. This is, the weight of something. This is how much space is inside it. They're not the same idea, but they're called by the same name. All right, so I'm just getting you ready for section 7.3. You're going to love the metric system. Well, we have to go through this. So let's do a few of these problems, get through it as quickly as we can. Don't hold your breath. Here we go. Let's take 36 hours, and we want to know how many seconds are in 36 hours. You do want to know, don't you? Of course you don't. All right, same kind of thing. You go back to the table, 36 hours, and you want to multiply by a fraction that cancels the hours and goes to seconds. Turns out you can't, right? Because nobody tells you the conversion between hours and seconds. What they tell you is that 1 hour is 60 minutes, and 1 minute is 60 seconds, right? So we're going to have to do 2 conversion factors here. We can't go directly to seconds. We can go to minutes, and then do another one which cancels minutes and leaves us with seconds. So you set up the units first, and then you go and get the numbers. All right, 1 hour, 60 minutes. 1 minute, 60 seconds. So that's where the numbers go, huh? Then you go ahead and do whatever you need to do. Hours go out, minutes go out, there's the seconds. So it ends up being a product like this, 636 times 60 times 60, big number, and that turns out to be quite big. 129,600 seconds. Wow. In 36 hours. One time someone figured out how many seconds there are in an average lifetime. It's several million or billion or something like that. But they do tick away. Yeah, they do. Okay, let's do a few more of these. Oh, here's a good one. I know you wanted to know the weight of an average male African elephant. What we're told is that it weighs about 12,400 pounds.
Oh, wow.
Now, most of us have no concept of that, so we want to convert to tons. How many tons is the average African elephant? All right, here we go. 12,400. That's in pounds. We want pounds on the bottom, therefore, and tons on the top. Well, luckily, that is in the table. You can look that one up. 1 ton is how many pounds? 2,000. Absolutely. So you end up with canceling the pounds, getting the tons. So you got 12,400 here divided by 2,000, and that will be in tons. So there you go, canceling some zeros. That's 124 over 20, and that's in tons. And when you divide that in, that's 6 and 4/20, 6 and 1/5, 6 and 1/5 tons. That's a heavy beast. Now you understand why they spend the whole day eating. They've got to support 6 1/5 tons. That's it. All they do is eat. Oh gosh. Now, on the other hand, convert the weight of a 7-pound, 3-ounce baby to ounces. My granddaughter was born at 5 pounds, 8 ounces. Let's use that so I can figure out how much she weighs. Okay, she's very tiny, 5 pounds, 8 ounces, and she's doing extremely well. All right, we want to convert it all to ounces. Well, one part of it's already ounces. There's nothing to do with the 8 ounces, it's already there. So we just have to convert to 5 pounds. Okay, so is there a conversion factor between pounds and ounces there in the table? Well, go back to 7-2. And we're talking about weights, 1 pound, 16 ounces. Huh? So 1 pound, 16 ounces like that. Okay, and again, everything cancels nicely. 5 times 16 is 80 ounces. So therefore, the weight of my granddaughter when she was born was 80 ounces plus 8 ounces. She was 88 ounces. Very tiny. And my daughter was very happy with that. It was a very, very easy pregnancy, very easy birth. She was happy she could be. And she's really gaining weight now. They gained 5 ounces in the first week. She gained 16 ounces in the first week. She's not wasting any time. Get this human thing done here, right? You know, it's so amazing when you look at these tiny little children, you realize we're not originally humans. They don't know what to do with this. Yeah. Walk? What's that? They have to learn everything. Okay, on page 421, you got some pictures, pictogram kind of stuff, and it shows you the relationship between fluid ounces, cups, pints, quarts. Now these are all capacity units, these are volume units, but they do it in a very nice way. Here you've got 1 cup, which we know is 8 ounces, that's the standard conversion. But a pint, it turns out, is 2 cups. Okay? A quart is 4 cups. A gallon is 16 cups. So they did it in a nice picture. It's just the table, but presented as a picture, that's all it is. So we can do some conversions there, and then we will all go home and be happy. Actually, yes, here we go. There's a really good problem. In this whole section, there's one good problem. It's on page 422, it's example 6. There's a recipe called for 1 3/4 cups of chicken broth. A can of chicken broth holds 14.5 fluid ounces. Is there enough chicken broth in the can for the recipe? So they want to take 1 3/4 cups and convert that into ounces, fluid ounces. All right, well the first thing they do is they take that 1 3/4 and convert it to an improper. 4 times 1 is 4, plus 3 is 7/4 of a cup. And then they do their multiplier, and the multiplier wants to cancel cups and go to fluid ounces. So you go back to your table, you find out that 1 cup is 8 fluid ounces. All right, so now you've got some cancellation even going on in the numbers. So you get 2 times 7 is 14 fluid ounces. Well, the can in the grocery store contains 14.5 fluid ounces. So is there enough chicken broth? Yes, there is enough chicken broth. You can do it. All right. So you had some more homework. I guess he gave you the rest of the homework.
Yes.
For 7.1. That goes beyond number 41? You have 47?
We got to 81.
81, okay.
Let's make
All
I
right,
wonder
so
if someone.
that you can do now, because it'll make sense about adding and subtracting issues. But here's 7.2. And then we go on to the good system, which is it's such a relief, it's unbelievable. And it was made up 300 years ago, almost 400 years ago. And it's French, and they never let us forget it. Okay, so that's 7.2. And tomorrow we'll do metrics.